All right, welcome everyone. We're going to get started. We have a lot of content to cover today. My name is Danielle Greshak. I'm a manager of solutions architecture with AWS, and I'm joined here with our customer and partner, Okta. And we're going to talk about development workflows with Docker and ECS. So what you can expect from today, first we're going to just review the CI/CD pipeline and some terminology there. We'll talk about how you would use containers with CI/CD. And then we'll have Okta Engineering talk about how they actually work every day and ship code, and how they do CI with Docker and ECS. So just to get our terminology down, so as we know, we all want to be doing continuous integration and deployment. It was a big aspect of Werner's keynote this morning. And of course, when you're doing continuous integration, when you check your code in, you're going and you're building that code right away. If you're doing continuous delivery, once you've done that build, you're taking that artifact that gets produced after some testing, and you're actually placing it in some test environment to be reviewed and whatnot. And if you're actually doing continuous deployment, you're actually deploying directly to production continuously. And this is really nirvana and what we all want to get to, and it really makes developers happy. And if you're going to be doing that, you also want to have a continuous feedback loop with your monitoring system so that you know and can understand changes in your environment. Just to level set here, the difference between a virtual machine and a container. You can think of a container as a lightweight virtual machine that runs on the operating system. And Docker really enables us to have these containers run and really eliminate dependencies, and so they can run very nicely, fast. And why do we want to use containers for continuous delivery? They really allow us to roll out features as quickly as possible. And they allow us to have this reproducible and predictable environment. They can run on any machine. And they are immutable. And so they give us this fast feedback for our deployments. So let's just review the application lifecycle doing software development. So first, of course, we start with our source code and working on our source code. And if you're going to do source code with if you're going to write code with containers, first and foremost, you're going to be using Docker and the Docker Toolbox. And you'll define your application environment with a Docker file. Here's an example of what a Docker file might look like. This one in particular is a Ruby application. And you can see some of the attributes inside of this. If you're going to be running multi-container applications, you're going to use Docker Compose. Again, you continue to define your application with your environment with your Docker file. And then you define the services that make up your application in a Docker Compose YAML file. And then if you want to start that, you just run Docker Compose up to start and run that application. Now to build your container, obviously you can use something like Jenkins. And in this case, we have an ECS plugin for Jenkins. And you can see in this console where here I am basically allocating a certain amount of CPU and memory to my container. And then I can produce a build artifact, again with this plugin, and push my image to my EC2 container registry. And that's exactly what this can do right here. And the EC2 container registry has a lot of benefits. You can set up security with IAM, and it integrates with CloudTrail, so you can see any actions on your registry. And you can very easily manage and deploy your images. It has very tight integration with ECS, so you can deploy your images directly from ECR to ECS. And it has integration with the Docker toolset. And most importantly, it's backed by S3, so it's highly available, reliable, and durable. So the next stage in our development process is running tests. So running tests inside of a container, you can just do the same Docker commands that you're used to doing to execute those tests. Here's an example, Docker run executing a rake test. And you can actually also run tests against your container. So you would start your container running in detached mode, and you'd have certain exposed ports for your application. And then you can run a browser test or other kinds of black box tests against those containers. So finally, we're going to go and deploy with containers. So first and foremost, you can do that using our EC2 container service, which is a highly scalable container management service. And it's very easy to manage clusters at scale with ECS. It allows for some flexible container placement, and we kind of talked about some new features added to that this morning. And it's integrated with other AWS services. And then the API layer is available for you to make it extensible. And some of the ECS concepts, of course, you're going to have a cluster that you'll work with, and then you'll have EC2 instances that make up that cluster. Those are instances that you still own, and you can SSH into if you need to. And then, of course, ECS works with tasks and task definitions, much like you're probably used to with other container management systems. You can also use Elastic Beanstalk to deploy your containers. And this really gives you the benefit of not having to worry about setting up a 3-tier application. It's kind of managed for you. You can have a 3-tier application with an ELB, your ECS cluster to manage your containers, and then that backend database and monitoring and logging is already configured for you. And of course, Docker support for Elastic Beanstalk is a single container or multi-container. Next, we have the Amazon ECS CLI. This is actually open source and available on GitHub if you'd like to view that. And you can easily create ECS clusters and some supporting resources, such as EC2 instances, to set up your cluster. And you can run Docker Compose configuration files using the ECS CLI. So just to give you an overview of some continuous delivery workflows before we go and talk about how Okta actually does continuous delivery. One example is to do continuous delivery to ECS with Jenkins. In this case right here, you can see we have a few steps where first a code push will go and trigger a build. And then Jenkins will go and build that image from the source. And it will run some automated tests as well. And then Jenkins goes and pushes the image to the Docker registry, or you can push also to ECR. And then the service basically gets updated through that, and the new image is pulled from the registry. And really, the benefit of this is that developers, all they have to do is merge into master, and then they're done. The Jenkins build steps can be triggered via webhooks, through monitoring or Lambda, and you can build your Docker image via build and publish plugin. You can also do continuous delivery with ECS using code pipeline. And so in this example here, what we're doing is we're using a code push to trigger a Lambda function. And this goes and creates a build instance for us. And what this does is then goes and builds our Docker image and pushes it into ECR. And then after that image is built, another Lambda function gets kicked off to terminate that EC2 instance. So this is done using custom actions. And then another Lambda function simply goes and triggers the update to the ECS service to deploy that new image. And this is something where it is a little bit more complex, but using those custom actions allows you the flexibility to do whatever steps in your pipeline that you need to do. Finally, if you're already using a third-party platform for CI and CD, you can integrate with some of our existing tool sets such as ECS and ECR. So in this particular example, this is a diagram where we have someone checking into GitHub, and essentially a webhook goes and triggers a build with one of our third-party partners, Shippable. And in this case, that goes and triggers that build, and then pushes an image into the EC2 container registry. And then finally, a notification triggers a deployment with shippable formations to go and deploy those new containers on ECS. So these are some examples of some continuous delivery workflows, but actually we're going to have John Todd, Chief Architect of Okta, talk about how they do deployment with ECS.
Awesome, thanks, Danielle. Hi everyone, my name's John and I lead the architecture team at Okta, and I'm really excited to be here with Tim, head of our developer experience and productivity team, to talk to you guys about how we're using ECS and Docker. So just to give you a little bit of context about what we do at Okta, I thought I'd give you a brief overview. Okta is used by millions of people every day to access their applications, any application from any device. And so, of course, we do provide single sign-on. We have a great experience, whether you're on a mobile app or in browser, where you can go to a single place and get access to all the different things you need to be productive with your day. But in addition to that, we've built a whole bunch of more functionality on top of that. User management, analytics and compliance, directory integration, multi-factor authentication, and mobile device management. And over the last few years, we've taken this API-first approach to building our product, and we've slowly been enabling more of this functionality that we originally offered to thousands of enterprise companies, and we're now excited to be offering it to developers. So I'm going to really just barely scratch the surface on what we're able to do here, but we'll boil it down into three things. Okta is able to connect to any data source. You could use the Okta directory, which has thousands of applications that it's connected to, including AWS as your user store. Or you could connect to a federated identity provider, your own database, perhaps running on-prem behind a firewall, Active Directory or LDAP, or a social identity provider. Next, we offer a customizable login and MFA experience, and there's a couple different ways you can go with this. You can either directly access our APIs, or you can use our login widget, which gives you the entire flow of both logging into Okta as well as account recovery and a full suite of MFA offerings, including our Push Verify and many of the other leading MFA providers with the click of a button. Lastly, we support all different types of applications with all the modern identity standards. So whether you're trying to create a portal where you maybe want to allow people to SAML into a bunch of different applications, or you're trying to create that accounts.google.com-like experience across many different microservices in your architecture using OAuth and JWT tokens with different claims for each application, Okta can help you build that. Identity is a very complex problem, and we've been working on it for 7 years. We have thousands of enterprise customers, hundreds of developer customers using our product. Please check us out at developer.okta.com. We'd love to help you with your identity needs. And so now let's move on to ECS and Docker, and why did we choose those two technologies at Okta? If you look at it, it really does boil down to the DevOps problem. And regardless of how you organize your company, whether you have a dev organization and a separate ops, or you call them DevOps, or you actually have each development organization own their infrastructure in production, you still have these two different conflicting needs. On the one hand, you're trying to enable agility and change, and on the other hand, you're trying to create stability. And one of the problems that we see is that you have this artifact that you need to eventually ship, and parts of the runtime environment aren't encapsulated in that artifact. So, in the Java world, we saw first maybe you were shipping some jars and the dependencies were already on the host that it needed to run on. Then Wars came out and that wrapped everything up together. Then Fat Jars and like Spring Boot and Drop Wizard brought that all into so that the container was actually inside that environment. But we've been waiting for a better solution for this, where literally the entire runtime environment could be wrapped up by development, tested, and have that same process that you're using development and in CI run in production. And so we knew that we wanted that artifact of deployment to move to being a container. And that was going to be one of the building blocks of our solution for breaking down this DevOps problem. Another part of that would be continuous integration. And we already had a good story there, and Tim's going to tell you a little bit more about what we've done there. And then the last thing we needed was something that was going to help us place those containers in production. So if you think about it, you want to have an abstraction layer between the actual hosts that your containers are running in and the definitions of those containers themselves so that developers can just say, I want so many of this particular instance running in production. Please scale up if CPU goes to a certain level. And they don't really care about the specific host that it's running on. Separately, ops wants to be able to go and upgrade the kernel or other changes to the underlying hosts without having to go and coordinate with each one of the different development teams to redeploy their software. That was our goal. That was the problem we were trying to solve. We looked at a number of different options. From a container perspective, we chose Docker because we'd been using it for a while. It had the most community engagement, but we do still keep an eye on Rocket. In terms of cluster schedulers, we liked Mesos for a lot of the BI workloads that we were looking at, and Kubernetes had an incredible number of features. But at the end of the day, if we looked at the minimum viable product that we were trying to ship, ECS was able to meet it. We were trying to just deliver stateless servers in production. And we've had a great relationship with Amazon where they're continuing to innovate their product as we start to use it. So we made the bet on ECS at first, knowing that it was the easiest thing to get going. And so far, it's been really great. I'm now going to hand it over to Tim to tell you a little bit about how we're using it with our CI pipeline.
Thank you. Thanks, John. Hi, everybody. My name is Tim. I'm on the engineering productivity team at Okta. And I'm going to tell you a little bit about how we use CI for our infrastructure on ECS. We use almost 100% Amazon services for what we do. And first of all, let's talk a little bit about what Okta engineering does. We have 200 engineers, which are split into many teams. All of them have embedded specialists. So we have UI engineers, test engineers, a bunch of different kinds of engineers on each team. We have 1-week sprints, and we deploy to production with our core product every week. Sometimes we do deployments more often than that if there are hotfixes, et cetera. We have the capability to deploy multiple times a day. We try not to do that. And every merge to master is a potential release candidate. We basically need to be ready to do a hotfix or to do a deployment whenever we freeze the code, whenever we decide that it's time to cut off developer work for the week. So in order to be able to do this, what we have to do is every topic branch has to go through the same amount of rigorous testing as a release candidate, as a master branch. And in order to do that, we have to enforce that all the tests are run before you can merge to the master branch, to the main line. And the way we do this is with our ECS CI system. Our largest repo runs 33,000 tests and currently takes about 60 minutes to complete the longest suite. And you can see there are 22 parallel runs right now. Some of our current work we're hoping to roll out in the next month should split that up into n parallel runs so that we can basically drive down that 60 minutes as low as possible. The smallest repo is maybe 100 tests, and it takes a few minutes to run. The developer productivity team that I'm a member of, we're responsible for making all of this work for the engineering team so that they can move as quickly as possible. So the first thing that we're trying to get for our developers is a good experience. They want to have a quick turnaround time. They want to have reliable results. They want to know that when they push their commits, their topic branch, they get back results. They know if they broke something in an area of code that they maybe haven't touched or they don't know about. Quality, we need all the tests to run every time. We need our QA department to know that we're running all the tests. And cost, we need to run the infrastructure as cheaply as possible for obvious reasons. You can't scale if your scaling comes along with a lot of money being spent. So we need to get the price down now so that as we grow, the cost doesn't go out of hand. And we try to use cloud first. This enables us to leave the background, the work on the servers to the experts, and we get to focus on increasing the velocity of our developers. So the problems that we need to solve within our engineering department, within our CI infrastructure, are these. So our CI was using open source monolithic applications. You can see on this diagram all of the boxes in red. Those are all individual machines that we have to manage. We have to deploy, we have to do security patches, we have to make sure the disks are clean, we have to do OS upgrades, we have to do all kinds of different things on every one of those boxes. That's where we were a year ago. So a couple of these, our Git puller, our queuing system, those have obvious replacements in Amazon. And those have been switched out for AWS SQS. And that was a pretty easy replacement. Some of the other ones, like our GLaDOS program, that actually talked to all of the different services, and it tried to figure out exactly how many slaves we should run, what type of slave should run, the environments those slaves had to have, and it was very brittle. And so this has been replaced by several Lambda functions, and I'll go into detail on those in a little bit. So these two are Java applications that we've written. There are test reporting applications and a little bit of analytics. And those are actually running on ECS in our, for testing right now, and we're rolling that out very soon. So the main focus for ECS conversion was our slave pool. This is where we save the most money. This is where we run the most machines. And this is where we can save the most time. So our vision for a new CI system last year was the following. We wanted to have clean testing environments. You need to isolate your test environments from others. Parallel runs if you're running multiple tests on one box, as well as serial runs if you've run other tests beforehand. If you give your developers the amount of latitude that we do, you will find that they can change almost anything on the host without realizing it, and it's almost impossible at times to get it back to a clean state. Dynamic worker scaling. Workers should not be dependent on their build server. It needs to scale very quickly. You can't wait for 30 minutes for a very complex server to come up and be prepared to run tests. The number of workers shouldn't impact your main reporting server. The reporting server should be able to scale and not be affected by the number of workers. We wanted to move to spot instances for cost savings. Anyone who's looked at spot instances knows that you can save many-fold on the per hour costs by using them. Another thing we wanted to do was versioned testing. We wanted our CI system to actually be versioned so that we can change the underlying infrastructure and have that be tied to a release that goes out and be able to run different infrastructure at different times on the same machines without having to worry about setting up a whole new system and then migrating all of the changes from that system to the old system or rolling everything over to the new system. And we wanted an improved queuing system. We wanted one queue, centralized, not tied to workers, just an empty bucket to put things in and then have all of our workers pull from that bucket as they could without having it be tied to a specific build server. We wanted less infrastructure flakiness. We wanted to push the development of the environment that tests run in and that software is built in. We wanted to push that out to the developers who are actually writing the software. So they can develop containers, they can develop Docker images, Docker files. We can push those out into our system and run it without having to spend a lot of time converting and building all these different systems for them, so we can focus more on the infrastructure that runs those Docker containers rather than focusing on setting up all the differences between them. And we wanted good privileges for so that we could have security. We could have basically all the teams in our engineering department using the same CI infrastructure and not worry about letting security credentials slip from an ops build to an engineering build, for instance. So the solutions that we came up with were to write a custom reporting app, and this is what it looks like. And this is our main product, and you can see the 22 suites that run at the same time. This has our custom policies and procedures built in. You can do promotions, you can do builds, deployments, things like that from in here. And then to use ECS and Docker. So by using ECS and Docker, we got immutable and disposable build workers. We launch them in a matter of seconds, and then we destroy them when we're done. We get almost zero cost on weekends. I'll show you a graph later. We can scale all the way up to as many as we need, several hundred, and then drop it down to running nothing on the weekends, or even nothing at lunchtime, or nothing at the end of the day. Sorry. It allows us to maximize the usage of our EC2 instances. With our old system, we had to run many different types of instances, and each type of instance had to have a specific setup. So you couldn't actually use one machine for different kinds of tests. And with using ECS, the only limitations on type of machines that we run are basically resources. So you can run more tests on a bigger machine. And the same AMI can run multiple Docker images, and some containers can be run for multiple types. Sorry, it reformatted. Another thing that we get from this is IAM separation. So we can use the IAM roles that Amazon provides us with to separate the access for different machines based on the cluster that they're running in. And so we can run multiple clusters within our CI system. Or with the new functionality, it's several months old now, but you can assign an IAM role to a specific task. And so then specific tasks can run in the same exact cluster, but have limited resources so that they can't actually access credentials or other things that might be stored in S3. Another thing we had to do in order to make this work is we had to share the Docker daemon between the host and the containers. And this is so that we can actually build Docker images on Docker containers. This is very important, and I can show you how we did that in the task definition later. Another thing that's very important was prefetching large bits of data. So if you have a lot of third-party libraries, you have a lot of code that you want to use, you don't want to keep shoving it into an image and having the image bloat so you have a 5 gigabyte image that you're moving around, that every time you want to spin one of these up, if you're spinning up hundreds or thousands of them a day, you don't want to be moving this thing around. So what we do is we put things like that, we stage them on the hosts, so that when the Docker containers come up, our system looks to see which ones are required for the job that's running, and it'll drag them over into the container, so it's just a simple move instead of network traffic. We also can run multiple containers on one machine, and so we can have third parties, libraries, third-party services like MySQL, Redis, things like that. We can have those in standard containers, standard images that we can just spin up for different tests depending on what they need. When we want to update Docker, it's very simple. We update our Docker files. The Docker files go through the CI system that's actually using the Docker images to run, and it will create new images, and then we can simply push those out by updating the task definition. So the CI system builds its own replacement. In order to do this well, there are several Docker conventions that we came up with. The Docker files live with the project code so that it's versioned with it, so that the images always go along with the code that built the image. We use Docker Compose, which is very similar to a task definition in all of our projects. So if we're developing a new project, we'll write a Docker Compose file, and if you run that Docker Compose file, it'll spin up a Docker container on your laptop, and it can spin up multiple other ones that are required, like the MySQL container that I mentioned in the previous slide. And you can have the entire environment up and ready to test against. Now, we convert that over into a task definition, and then in our CI system, we can spin up small constellations of containers which give everything you need, build the environment, a complex environment for an integration test to run. All of our library and third-party services are in a single repository, and this makes one place that we can all share. It's all reviewed. We make sure that we don't pull the strict rules around from clause. We don't pull from outside sources for base Docker images. We always build off of internally trusted ones that we store in our own repository, be that ECR, or we use Artifactory for some of our project builds. And the build actually owns creating the images. As mentioned earlier, we pushed out building the environments to the developers so that they can build their own environments and write the scripts to build those containers, build those images, and then we can just run them. Here's our build process. you can see that at the top, topic branches are built and not stored long term. Once somebody merges to master in the middle row there, then it gets pushed into Artifactory or ECR. And then once they run a promotion, which means they want to release this version, then it searches in ECR or in Artifactory, finds the master built image, and then it promotes it, and it just moves within the repository to a new location. And then that new location is available to our Conductor deployment app. So here is part of a task definition. And you can see the interesting things about this one are there are resource limitations, so we can tell it how many resources this task will get when it runs. So if you have a larger box, you can give it more resources. If you want to run multiple containers on one box, you might need to give it lesser resources. An interesting thing here is essential true. We found that if you want to run multiple containers on one machine, if you start them all up using the task definition, if one of them doesn't start, then the other two might actually start up and try to run against them. And so by putting essential true, it makes sure that all of them are up and running before the task actually begins to run. Also, this is how you share your Docker daemon so that you can build Docker images from within a Docker container. And these volumes that are mounted can be used to access stores of large bits of data that are on the host. So what did we get by going to this in moving toward our vision? So we got clean testing environments. Docker images are completely fresh every time they spin up, and they spin up in seconds, literally seconds. So when we're done with a test, we report back the results to our reporting app, and then we just start a new one. It starts up in a few seconds, and then we start our setup, and we're ready to go. It's easy for users, for our developers, to develop their own images and upload them, and then we can run them in our system. It's much more efficient. It uses all of the machines, because when something's done running, we throw it away, and we can run something else on that machine. And we get ECR, which gives very good access for pulling down images to run, and it's safe and it's very responsive. So let's look at how we did dynamic worker scaling. We use SQS and SNS to get our jobs in the queue. So when we want to run 7 new tests, we put that test list into SQS. There we have Lambda, 2 Lambda functions read that. One of them is a scaling function, and one of them is a bin packing function. Now the scaling function will go and look at the existing machines, the EC2 hosts that can run that job, and see how many of them are there, and then it makes a determination if the buffer is great enough or too small, and it will launch more machines or not launch machines, depending on how big the buffer is. And then the bin packing machine will actually go and try to shove all of the jobs into the smallest number of slaves so that we can always keep our slave pool as small as possible. And you can see how bin packing works here. So when a new job comes in, it goes on a new machine, and it's running, and then that job finishes. That job finishes. Now when a new job comes, with bin packing, it's the one on the right, where all the jobs are in the minimal set of slaves. And in the way that ECS naturally works, it spreads out the load over as many hosts as possible. Now, when the auto-scaling looks and decides to shut down one of the machines, it can pick any machine here, and often it will shut down a machine that's running one of the jobs. So we want to shut down the machine that's not running the job. So the way we do that is we deregister the slaves that aren't running jobs, and we let them introspect and then shut themselves down when they're no longer running anything. Here's a chart that shows this one goes up to 120, which before we rolled this out, we were running 120 slaves at a time, every day, all day. And then when we rolled this out, you can see we're saving almost as much money as we're spending now. So we went below 50% of our spend before that. So we use spot instances across all availability zones, and we have to manually switch between them. And This isn't ideal, and so we're planning on trying to move to Spot Fleet soon and see if that helps at all. You can see the variability in our Spot instances here. The lines at the bottom are what we expect to spend, and the spikes are what happens on a pretty frequent basis. These are the notifications from Amazon. They tell us when the Spot instances are going to go down, and we can actually requeue the jobs that are running there. So here's how much we've saved. You can see the green is what our team spends, and we saved almost as much as we're spending. I think it's 20% of the total spend in our greater group here. So we also get version jobs by doing this. You can see that we have developers checking in changes to the build scripts, and this allows them to make changes to the CI infrastructure as they need to their environments as they need to. This allows us to run different versions of containers, task definitions. It creates extreme flexibility, and CloudFormation allows us to set up whole new clusters with different versions in a matter of minutes. And we've done this before for some of the teams when they needed their own isolated environment. So some of the problems that we've run into were early on were Docker containers not launching, ECS agents failing, Docker containers stopping. We solved a lot of these by just updating to the latest versions, and a lot of that went away over the last few months. We also just use SQS feature to requeue tasks that have disappeared. And some of the other problems we have are incompatibility with certain services. There are a couple things. There's a JS unit testing framework that will actually break the kernel. So we can't test some things on Docker. We can't run Windows on Docker very easily. Cleanup, we were filling up the disks. Amazon has since enabled cleaning up at a shorter time period. And image size was a problem. We solved that by moving large bits of data to the hosts ahead of time and then just having them mounted when we need them or copying the data over when we needed it. So these are all of the services that we use in our CI system. And this is what it looks like now. So almost everything is green. The only actual machines that are being used there, where we actually have to worry about the size of the machine and security patches, et cetera, are Bacon, Aperture, and Flakenizer. And Aperture and Flakenizer are being tested running in ECS right now in containers. And we use them to roll out test code before we roll it to the production server. And so those will be switching over very soon. And Bacon is actually in Elastic Beanstalk now, so it's managed as well. The blue square denotes a template so that we can launch all of that at once. And the yellow is our underlying reporting system. So we keep one of those, and we can launch as many of the blue ones as we need for different teams. So in the future, we're looking to use ECS for more services, to have the teams just use it for more of our products that Okta is writing. We want to allow developers to have more access to the CI system so that they can actually roll everything out without us having to make any changes on the back end. Currently, we still have to get in there and work with it and change some stuff in the database and move things around in order to get their new Docker images onto our system. And the developer environments are currently using some of those third-party images that we talked about, but they are running the same version operating system as our CI system and very similar to our production system. And so we're trying to keep the developer environments up to date with the CI system. So we roll out updates at the same time, and the only thing that we have left to do is we'd really like to have the CD containers, the CI containers, work on the laptops right away, but CI has IAM access to certain resources that a developer might not. So we just need to do some work around making sure that their credentials will work with the containers when they launch them. So now I'm going to hand it back to John, who's going to talk about the services we're putting in production.
Thanks, Tim. So yeah, I'm going to talk about two things, how we're using ECS in production and how we decided that it was the right thing to do. And I'm going to do a little bit of a demo of our tooling. So for production, we had a few requirements that were separate from what we were thinking about internally for CI. We needed to support our multi-AZ, multi-region architecture, Multi-AZ you get for free because ECS runs on top of EC2 instances. But multi-region meant that we did need to wait for ECS to be available in every region that we run in. Amazon also, Okta also has a number of different compliance requirements that basically enforce two different things for us. Enforces that we use least privilege principle, which for us means that we needed the services, the IAM roles that were granted to services to be distinct for each container and each service. We also needed to continue to have the host-to-host encryption that we had in place prior to using containers. And again, because ECS is just built on top of EC2, we get that for free. Next, for deployment support, we wanted rollback. You get that really easily by just telling the scheduler to go back to the previous version you're at. And then we also wanted canary and blue-green deployments. And that's possible with the later changes to ELB, the application layer ELBs that they're offering, where you're able to have multiple services behind the same ELB. And so whether it's a production and a canary service, or it's a blue and a green service both behind the same ELB, you're able to now do those sorts of orchestrations that you'd like to do with your containers. And then lastly, and the most important to us, was zero downtime deployments. And at this point, this is mom and apple pie for all of us, right? We need to ensure that our services are up and running all the time. But we wanted to take it a step further, right? If you look at the state transition diagram for ECS, it's pretty complicated. There's a lot of different ways that you can change state. And we wanted to make sure that across any of these different operations that we might be performing, we ensure that our customers aren't seeing errors or failed responses. So I wrote a small little app called Aries, which is named after the beater car I drove in high school. And it's a beater app. It lets you do things like fail health checks or simulate latency or other types of issues. You can check it out on GitHub if you're interested. There's a container that you could just run and do the same tests that we did. The test assumptions we made, we used the 1.11 version of the agent and Docker. We're running this on top of an auto-scaling group, which is providing the underlying EC2 hosts. And we're using some of the most aggressive health check thresholds that you can for ELB. And then most importantly, we've enabled connection draining, which is incredibly important for all of this stuff to work well. For our tests, we did two different types. We generated load 16 threads on a first type was interactive, where we just sent the request to the service and have it respond as fast as it possibly could. With that, we got about 490 requests per second. Then we also simulated a model that would be like long polling, where you make the request, the backend holds it for 10 seconds, and then it responds. We want to see now, if we go through all those different state transitions in that diagram, how does ECS do? So it did well. Most of the operations, in fact, all of the operations that you're going to do in a normal day are going to work just as you would expect them to. We didn't see any loss. If you look at the row at the bottom, kill the Docker container, this is a convoluted scenario. We decided, hey, what would happen if you actually log into the EC2 host and just say Docker kill container ID? And I was actually really impressed. So at 490 requests per second, only 2 of them got through before the agent told the ELB to take the service out of rotation. That's pretty impressive. The other weird thing that we saw was when you actually went and stopped a underlying container instance, rather than terminate, just stop. It puts the system into a weird state. And I don't know if they've gone and fixed this, but when you're stopping an instance, it's not really clear whether or not your intent is to have it to stay in the cluster because you're going to restart it again later, or you're going to actually terminate it. But we found that if you stopped and then terminated the instance later, that termination never made it back to the cluster, and the cluster kept holding on to that instance. And it would, in fact, try to schedule onto it, at least in the earlier versions of the agent. So the one odd thing I would say is just avoid stopping your instances. Just prefer using terminate instead. Then the last thing, when your health checks fail, obviously you're going to get errors. That's when it's your responsibility to keep your application up and running. So the way to get those numbers lower there is just by having the right tuning for your health checks. So as Tim mentioned, a lot of this workflow starts with developers in their Git repos defining a Docker file and a Docker Compose file if they're trying to stand up multiple dependencies of the service that they're running. But then there's also an application YAML file, which declaratively defines a bunch of different aspects of that application. It's used for the CI pipeline, and it's also used by Conductor to define how the deployment out to ECS should work. And Conductor is our lightweight little application that allows developers to just update versions of code that has been promoted. Here's a quick look at our YAML file. At a high level, there's kind of two different things there. There's a definition of components, so you might have a UI and a back-end component. And then you might have some number of tasks that you're able to perform on those components. The YAML document is able to have properties that get replaced at deploy time, and then secrets are never put into this system, but instead are pulled by the application at startup time and only kept in memory. So now I'd like to just do a quick demo of some of our tooling. So in this demo, I'm going to have two different personas. One persona, John, is going to be a consultant who just got hired at a company called reInvent. And the second persona is going to be an administrator named Tim who runs IT for the organization. And let's see if the Wi-Fi gods will allow this demo to work. OK, so I just received my credentials to start working as a consultant for the reInvent company, and I'm going to log in. And I'm walking you through this experience because everything you're seeing here is something that you could put in front of your application without doing any coding, because we have a login experience, a widget, and this is the look and feel of that widget. You can customize the CSS, et cetera. So now I'm going to set up Google Authenticator, but you could use this in your app. You could pick whatever factors you want to use. I'm just doing this to demo the fact that it's not just a login page, and it's not just an account recovery email that you need to be able to send out or an SMS, but there's a lot of different steps in a login flow. There's the onboarding of an MFA factor, which I'm going to do right now. There's also the challenge of an MFA factor, and how do you allow people to reset those as well? So all of that's encapsulated in a single page app that we allow you to host and run in front of your application if you want. All right, so I'm going to finish up this setup of MFA. And I could configure some other factors, but I'm not. I'm just going to go in. So as a contractor right now, I only have access to GitHub. But Okta enables me to also self-service access additional applications in my company if someone's made it available to me. So I can go ahead and add Bacon. And Bacon is our UI for CI/CD. And now I've got assignment to Bacon. And I have an account that I can use and access Bacon. It was that simple. Now let's fast forward time and say that I get hired as an actual full-time employee. And so maybe that means that our HR system just moved me into the full-time employee group, and then that got synchronized to Okta, and Okta puts me into the group that way. I'm going to simulate that by just going to the full-time employee group here, managing people, and adding John into that group as the administrator. And now when I come back to my home page and refresh, I now have access to all the other applications that are given to full-time employees. And Okta's gone and actually provisioned accounts in all those systems and allow me to now get access to Amazon, Google, GoToMeeting, and Conductor, which is our deployment system. So you can see we're mixing in here internal microservices that we've written with cloud services that we use. And this is a model that a lot of us probably have, where you have a bunch of applications you're writing yourselves. You want a single place to go and authenticate in. But it's not just single sign-on, because you also want your internal applications to get attributes about your users so you can make authorization decisions, right? So when I go into Bacon, I want it to know that I'm in certain groups in Okta so that it can make decisions about whether or not I'm allowed to promote certain artifacts. So I'm going to now log into Bacon. And in this scenario, this is the only part that's actually going over the Wi-Fi, which is why it's probably a little bit slow. We're going and doing an SSO into Bacon, providing it with a set of claims about my user that Okta has specifically put together for this application. Okay. So we're in Bacon, and Bacon is the UI that sits on top of the rest of our CD pipeline. We're looking at the Sage repository right now. It has fewer components than what you saw in the demo that Tim showed you. We have a backend app and a UI, and you can see I've got this JT demo branch here that I was working on earlier. I had a failure that I needed to fix, so I could go in here and download log information for it, figure out what the issue is, realize that it was a flaky test that someone else wrote, and I can do a selective retry. And if that's not the fix for it, maybe it was actually a bug that I introduced, then I can go ahead and fix that bug, re-push a new branch, and then I'll have the option to merge. And so something that a lot of organizations have a problem with, but they don't talk about, is the fact that you have flaky tests, right? You work in a big environment with lots of different folks changing the code at the same time. You're going to have flakiness. And so one of the other things we've built into Bacon is the ability to track statistics about our tests and understand what their likelihood is of actually being successful and what teams own them, and use this to start to track what commit introduced the flakiness for this so that we can use that for assignment. The last thing I'll show is just that if I click merge, I'm able to put in the JIRA. So we're able to start enforcing some of the things that we require in our environment, that every change has a JIRA. It's also pointing out that I haven't squashed my commit, so encouraging me to do that. And then if I've made enough commits and I'm ready to go and push a deployment, I can promote the artifact. Now, in this case, I'm not allowed to do that because the user that I'm trying to do this as doesn't have that capability, which is informed by Okta. So what we're demoing here is a UI that's powered by Amazon for its scalability. If we have more tests, if we need to break these up into smaller chunks so that they, in aggregate, will run faster, we can do that, and Amazon ECS powers that. And then we're using Okta to enable SSO and authorization federation. All right, so I'm just going to end with a couple thoughts. We had a number of feature requests that we wanted to see in ECS, and as the time got closer to coming to this conference, more lines started getting drawn through this slide. It's awesome to see that they've added dynamic port mapping, which allows us to put multiple of the same service on the same machine. It's great to see that they've added service auto-scaling so that we don't need to start doing that with Lambdas ourselves. It was awesome to see the per container IAM roles. We'd still like to see per container security groups so that you can lock down your network policy as well on a per container basis. And then the announcement earlier today of the open sourcing of more capabilities around ECS is really exciting, but we'd still love to see a bin packing scheduler that doesn't require us to stand up anything else. But it still steps in the right direction, so that's really awesome. Lastly, some lessons learned and takeaways for you all. If you're not familiar with the ECS config file, definitely look at the various options in there. In particular, the cleanup wait duration is pretty helpful if you like to sleep at night. And the default of 1 hour is not all that easy. It doesn't make it easy for you to get your forensics done if you're going to wait 8 or 9 hours before you're going to take a look at it. We've also found that at times when there were issues with the ECS agent early on, turning on debug mode really helped us figure out what the problems were. Sometimes they were ours and sometimes not. Definitely tune your ELB health check, right? So when we did that test, we did find that really the only place that we were going to have failures for our customers was if our own health checks were failing. But you do need to be on top of getting the right tuning for that. Upgrading to Docker 1.10 or higher has a number of security enhancements, including allowing your containers to run as non-root users in the event that someone could escape your container. That's a pretty important change. Also, take away, canary and blue-green is possible if you have multiple services behind the same ELB. So I'll just leave you with the fact that we think ECS is incredibly easy to get up and running. We've been really happy with it thus far. The ecosystem is changing all the time, and as we saw even with the requests that we've had, Amazon is really keeping pace with this. So we're really excited to see how it continues to progress, and happy to be a partner with you guys. So thank you all for coming. We'll be around here, but not taking questions right now, but we'll be around here after the presentation. Thanks again, and feel free to reach out on Twitter or email if you have questions that way as well.